Okay, welcome back to, I think, probably the final part of the tutorial 6, which I've been doing early this week. So we're having a look at question 8. So question 8, we're looking to understand how we can get the theta of this. So sine theta is equal to 0.62. So we do the inverse or the arc sine, it doesn't matter, they've all got the same. And what you do to one side, you do to the other. And so that decimal will come out as theta, because this is undo. So theta will equal. Now to do that, it's specified in the question that it's degrees, so we're not worried about changing anything. We just take those values verbatim, don't worry about them. And so 0.62. Trigonometry, second function shift, I think it is in yours. And sine, so we get 38, approximately 38.3 degrees. Okay, so it's just a case of doing cos to the minus 1. So cos to the minus 1, doesn't matter whether you use, don't worry about the decimals, the decimal angles, it's not important. Okay, so we're not worried about that. So arc cos is another name for cos to the minus 1. And what you do to one side, you do to the other. It's just, I'm writing it so that you see it. Okay, it's not important on one level. It's the same as sine to the minus 1. Okay, so in fact, to be so gracious, what I'm going to do is do cos to the minus 1. It means the same thing. It's undo. Okay, it's undo. Both of these are going to give you theta. So that's the same thing. And so cos to the minus 1 minus 0.4. Okay, so it's the same thing. So in the calculator, you're going to be doing second function, 0.41 minus, and second function for cos to the minus 1. So 114.2 degrees. Very straightforward. Don't be concerned about arc cos, arc sine. They all mean the same thing. Arc sine is equal to sine to the minus 1. Arc cos is equal to cos to the minus 1. Arc tan, if you see it, equals tan to the minus 1. So some curriculum systems like to use one or the other. They're the same. Okay? So don't be bothered by that at all. Alright, C equals tan theta. So we could do arctan. Undo. Very unfamiliar, isn't it? Because you may not have seen it before. Arctan tan. Tan theta. Yeah, that's undo. So theta is arctan or tan to the minus 1 as it shows up on the calculator. So 2.1. Second function, there it is, see? 10 to the minus 1. So it's 64.5 degrees. Nothing too dramatic about those, okay? What else have we got? Sine minus 0.08. Arc sine. Sine theta, sorry. Undo. Do the other. Now I'm putting that in because some textbooks in 4-unit maths or some questions or some material you see in 4-unit maths will have arc sine rather than sine to the minus 1, but it's the same thing. Okay, the really important point here is that you understand it's the same thing. Alright, 0.8 minus second function. What are we looking at? Sine minus 53 degrees. E. Just using your calculator skills, isn't it? Sec theta 3.2, so sec is cos, isn't it? 1 over cos, but in any case we get sec to the minus 1 sec. We'll just reveal theta because this is undo. so sec to the minus 1, which is equal to minus 3.2, second function trig. Hang on, it's confused. I did the pressing of the button. Second function. Now, what do I say? Sec. Here, 108.2 degrees. So it's a very straightforward proposition. Okay. I think what you need to do is just recognise when to use your calculator and when to use those skills related to exact values, G, proportion, sine, etc., etc. All right, so question 9. So sine 585 at a first instance looks horrific because what on earth is going on? But all this means is that it's gone around once, so that's 360, and 360. Now I could divide 585 by 360. Now, or I could just subtract 585 by 360. That would be the easiest thing to do. So, not from 5 is 5. Now, 6 from 8 is 2, and 3 from 5 is 2. 225. So it goes again. Now, 225. Just subtract 180 from that, just to get where the overs are. Okay. So 8 from 12 is 4. So it's 45 over. So it goes around again. This is the interpretation and comes in here. So this is our triangle that sits with a 1. They're both the same size and they're both negatives. Negative x, negative y, the hypotenuse of 1. So this is actually asking us what is the angle that is an equivalent to this. Okay? What is an angle that is an equivalent to this? So it's also asking for the length of, so we use our association, we use our proportion, and we use our plus minus. So these are the three things we use here. So sine tells us it's looking for y. This quadrant here, the way that it's looped around, tells us that it's a minus. So it's a minus y. So that's those two out of the way. And then the proportion is, it's the same size because it's come in at 45 degrees. So that's just taking off the bits to find out where it lands. And so 45 degrees, so we go like that. So 45 degrees. Actually, you know what I'll do? I'll just take the loopies off just for the moment, and I'll just put our unit circle on, just so that we have a sense of that. And then we'll do the looping in a different colour. And so we're starting off, we go around once, 360, around again, 225. Okay, so we go around one more, and then we come in here. So this one here is our 45 degree in the third quadrant. Okay, so we're going to count. 1, 2, 3, 4, 5. Okay, so to get these results, we need 5 lots. Now, what did we say the angle was? Because they're the same, because it's 45 degrees, it's pi on 4. So for this particular one, it's 5 lots of pi on 4. Okay, so that's our actual theta. That's this one here. But this one here, I'll join it so that it's clear. So that angle swoop there is 5 lots of pi on 4. 1, 2, 3, 4, 5. Of course, it's hidden in the fact that we went around 1.5 times to get there. Okay, so in this case here, we're looking for y. So that's this one here. Aha. Now what's that in a unit circle? It's 1 over root 2. Okay, 1 over root 2. So let's test that out and see what that looks like. So the first thing I want to do is get the decimal of that. So let's just clear all that rubbish away. 1 divided by 2 the square root is equal to 0.707. Now that's an RMS value for you people that are physics buffs. 0.707. So let's go with that. Sine 585. Now we're not using the calculator because it says to do it without a calculator, but we're checking. So we're using technology to check. So 585 trigonometry sine 0.707, and that's all right because what it means is I didn't put my y sign in. Minus and minus, but I did nominate that it was negative, didn't I? I said it out here. So we're looking for, this is our answer. That angle goes together with that y, because sine is y. Okay, so that's all we do. It seems like a lot, but once you get this down, you'll be very, very happy with yourselves. Okay? All right, let's have a look at B. Now, before we go worrying about tan, we're looking for 660. Now, 360, let's take 660 minus 360. So, 300 degrees. Now, 300 degrees falls short by 60, doesn't it? So, in our 300, we go a 60 degree, that's this one. So, the angle is going, that's our theta. So, 60 degrees is in our unit triangle this way. This is how I've taught you to do it. Count around. 1, that's not included. 60 plus another 60 is 120. 2 plus another 60 is 180 plus another 60. That's not in it. So another 160. So that's it. So what we've got is 1, 2, 3, 4, 5. So we've got 5 lots of. Now what was this angle here? The base angle theta was the bigger angle has a smaller denominator. So the angle that goes with that is there. Now this one's asking for tan. What's tan? Well, tan is opposite over y over x. Okay, so this is root 3 over 2 minus, and this one here is plus a half. Now, where am I getting those from, people? White sheets. 5 or 6 weeks of white sheets. Recognition. Okay? So this one is minus root 3 on 2 over half. So minus root 3 on 2 divided by a half is equal to minus root 3 on 2 times 2 over 1, which is minus root 3. Now let's get the decimal of that. So that's the answer. Okay, we're happy to have that. So that's minus root 3. That'll be the answer. Okay, exact values trig. This is what you need. This method that we're using is more important than the actual result, but the method is the thing that's going to help you in the other topics. All right, so just going back to our calculator. What did we say it was? 10, 660. 10, 660. Okay, now minus 1.732. So what did I do? Root 3. So we've got to do 3 square root and put a minus on it. There it is. It's the same one. So the technology helps us to check, but our thought was the minus 1.72 ... Okay, so the exact value is correct. So we did the right thing there. Okay, and it's all just counting around and doing counting for that part. So very straightforward, but you know, I've got to do it, haven't I? I've got to do it with you. All right, let's have a look at C. We've got cos 960, so it's an x. It's looking for an x value. We don't know the plus or minus or anything yet. Now 360, how many times does 360 go into 960? I'm going to do it on the calculator because I'm suspicious. 960 divided by 360. No, I can't even get the buttons to press right. Divided by 360. Let's try that again. No. So we'll go back to our drawing board. So we're going to do 960 minus 360. So that's one loop. Then we'll take off another 360, which is another loop. So we're going around. We've been once. Now we're going again. So that's 0. 6 from 10 is 4. That becomes 4. So that's now 240. Okay. 240 is less than 360. So 240 is less than 270. So 180, 270. So it's in here somewhere. And by how much? So by how much is I'm going to take off the 180. So the second trip around will be 180. So I'm going to minus 180. I want to see the overflow. So 6 and 8 is 14. So, oh, look, it's 60 degrees. So there's a 60-degree triangle. That's what it's telling us. Okay, a 60-degree triangle. So we've got to come back to exact values trig. Okay, and we've got to put our 60-degree triangle in because there it is. That's the equivalent. We've got to dress it up if you want to. So there's our 1. There's our minus a half. Minus root 3 on 2. Now this one's asking for cos, so we use our associations. Okay, so the big one around is this one. That's 240. That was this one. Okay, that was your 240 degrees. Now, the base angle, theta, is what? By recognition, theta is the bigger angle has the smaller denominator. Okay, now how many counts did we get? It's the same as the previous question, isn't it? 1, no, 2, 3, yes, 4. So this is 4 lots of pi on 3. Okay, 4 lots of pi on 3, whereas that one was 5. So that's the one that'll give you the same answer. Okay, now cos is only looking for x, so therefore this is equal to minus 1/2. That's all we've got to do. It's just asking for the length of x. Length of x at 240 degrees or 4 lots of pi on 3. What's the length of x at 4 lots of pi on 3? Okay, these are the things you need to do. Okay, 4 lots of pi on 3. That's lots of. Times is lots of. That's why I write it this way. Okay. Okay. Okay, so now for D. Now the beauty of counting around, of course, is that negative angles present no real drama. Okay, so what we're doing here is we're going this way. Okay, minus theta. So we go, so let's do 5, 10. Let's see how many times we go around. 6 and 5 is 11. 4, so it's 150 degrees now. Okay, so it's 150 degrees. So it goes a whole loop. Round you go, a whole loop. Then it goes another 150 degrees. And 150 degrees is just 30 degrees less than 180. So if I took 30 degrees less than 180, okay, so I'd go 0, 90, 180, but I only had to go 150, which is 30 degrees less. So that base angle there, the small angle, is the bigger denominator, okay, in that direction. Very good. And because we're going in the negative direction, it doesn't matter. Right, so we do our counts. So we've got 30, 60, 90, 120, and 150. There you go. So we go, ready? Count. 1, 2, 3, 4, 5 lots of pi on 6, but it's in the negative direction. 5 lots of pi on 6. Okay? Now sine, we probably didn't need to do any of that, but I just wanted to help you settle the argument about how far it is, right? Was there an equivalent? So this one here, by visual happenstance. We can calculate that. We'll do that in a little while. But for now, I just wanted to get this. So this is a y. It's looking for a y. So we've got our three things of association, sign, and proportion, and sign. And so, or plus minus. It's a negative y, and it's a short negative y. So the short negative y is going to be minus a half. That's root 3 on 2 for a 30-60 triangle. And so it's root 3 on 2. Right, so that's our 5 lots of pi on 6 and that base angle. So I really should just correct that little line there, just so that we can do that. So the little base angle there is just the pi on 6 bit. And this one here is the minus 5 lots of pi on 6. Counting, it's very easy to do. Alright, so this is a minus a half. Done. Okay, very, if you can count, you can do this stuff. So we'll just check it, just to satisfy your curiosity. So 510. And what are we going for? The y minus a half. Easy. Okay, so that's how we're doing it. Now, I'll do some more on these. I'll keep hammering these because it's important for us to get that out of the way. Alright, for 10, convert the following to degrees. Well, really it's recognition, isn't it? Pi on 6, the smaller angle has the bigger denominator. 3 lots of pi on 4. There's your pi on 6. Okay, 30 degrees. Now, 3 lots of pi on 4. Pi on 4 is here. So 1, 2, 3. 3 lots of pi on 4 is 3 lots of 45. 3 lots of 45 is what? 90. 3 5s are 15. 3 4s are 12, 13. 135. So 135 degrees. Okay, lots of. You've got to get used to doing it. Lots of. Okay. 5 lots of pi on 6. 5 lots of pi on 6. So pi on 6 is the little one. 1, 30, 60, 90. Okay, there it is. 5 lots. So we get to that side. 1, 2, 3, 4, 5 lots of 30 degrees. 5 knots are not. 5 3s are 15. 150 degrees. It's not rocket science. Okay. 11 lots of pi on 6. Oh, I like doing this one because this one comes up a bit. 11 lots of pi on 6. There you go, 30 degrees. 30 degrees as the bigger denominator. That's why I chose it. But I want to go 11. 1, 30, 60, 90, 100, 120, 100 plus 30, 50, 180. Okay. 180, 210, 240, 270 is part of it. 310 is part of it. Okay. Oops, 10. And then this one here, 11. 310, 340. So that's the equivalent. Count around all that way. That's that one. Okay. So it's 11 lots of pi on 6. 11 lots of pi on 6. Easy. Okay. So what did we end up saying it was? 340 degrees or 340, 50, 60, 3, 7. No, that's not right. That's 330. That must be 330 degrees. Let me just check that again. Counting again, please. Okay, let's go again. 30, 60, 90, 120, 150, 180. 180 plus 30 is 210, plus 30 is 240, plus 30 is 270, plus 30 is 300, so 300 is here. The 10 count is 300, so I'll just remember that. 330 is 11. Okay, 330 is 11. Okay, up in 30 degrees, and 360 is all the way home, so that makes perfect sense. So the angle is 330, 11 lots of Pi on 6, you must do it this way, okay? Don't worry about anything else, just follow this. Now, 7 lots of pi on 4. Pi on 4 we know is this one, 45 degrees, okay? So we can count. We can count. All we need to get to is 7. You ready? 1. It's included. These are 45, 90, so that's included. 3. That's included. Sometimes the 180 is included and sometimes it's not. Or the 90 is included and the 180 is always included, but the 90s are sometimes not. 5, 6, 7. So there you go. That's 7 lots. That's the one we wanted. 7 lots of pi on 4. Now, how does that help? Because 45 times 7. 7 5s are 35. 7 4s are 28, 29, 30, 31. 315. Because it's in 60 degree increments. Okay, so 315. And the final one's pi on 7. So pi on 7, because it's not an exact value, there we will single it out. 5 lots of pi on 7. Everything else was exact values trick. This whole thing can be done by sight. Okay? No calculator. Using exact values trick. Very good. Now, the thing is, what we have is one that's not. The idea is still the same. Okay? But pi on 7 isn't necessarily a multiple of anything, nor is it an easy pick in terms of degrees. So we're going to have to use the unitary method. Okay? So what we say is that pi is equal to 180. Oh, okay. And if we divide by 180, we get pi on 180 is equal to 1 degree. Okay? So the other thing we can do is divide by pi. So pi is equal to 180 divided by, 1 radian, gee whiz. 1 radian is equal to 180 on pi. Okay? Now you can use these results, degrees and radians, to work out this now. So we want to convert 5 pi 7 on radian. So we do it over here. We use this one, and this one. Okay? So if 1 radian is 180 on pi, 5 pi on 7 radians is 180 on pi times 5 pi on 7. That's all we're doing. Okay, we're just multiplying 1 by 580 and equivalently this by 5 pi on 7. Okay, 1 by 5 pi on 7 gives you 5 pi on 7. All right, so we can do some cancelling. Now, 7 doesn't go easily, does it? 2 7s are 14, 40. 7 5s are 35, 6 7s are 42. So this is going to be 5 noughts are naught, 5 8s are 40, 5 1s are 5, 6 7 8 900 on 7. Okay, now that's degrees now. That's come out in degrees. Okay. So we had radians on that side and degrees on this side. So 7 into 90, 7 7, 7 9s are 7 10s, 7 11s, 7 12s. Well, 7 into 9 goes once, 2 left over, 2 7s are 14, with 6 left over, 7 7s are 49, 7 8s are 56, with 4 7ths left over. Okay, so that's all we're doing. Very straightforward. You can use your technology to check that as well. Okay, you can actually type in to Wolfram 5 pi on 7 in degrees and it'll tell you the answer, but I'll let you do that. Alright, so I'm going to come back and finish the last 3 questions on another video because we've managed to get to half an hour, so I'll be back soon.